All right, guys, welcome back to day 2 of exponential functions. Okay, so I'm going to reiterate some things that we should have learned in day 1, and I'm actually going to go over some specific cases that may have came up in day 1 that'll help you complete the rest of your assignment. Okay, so yesterday we talked about, or you should have listened to the video that talked about y equals a times b to the x, where a is your starting amount, b is your multiplier or how you're growing, y would be your final amount, and x is what's changing. Usually we do things with time. Okay, so let's get right into it. So an example, Matt bought a new car at a cost of $25,000. The car depreciates approximately 15% of its value each year. How much will it be worth in 1 year? Okay, so let's set up our equation. So we have y equals a times b to the x. So if you imagine y equals a is going to be our starting amount. It starts out at $25,000 times, now remember again, to get b, okay, first of all we start out with 100%, and since we're depreciating, we're going to subtract 15%, which takes us to 85%. Okay, so changing that into our multiplier, I get 0.85 to the x. Let me draw a better x. Okay, so then how much will it be worth after 1 year? Okay, well this just means I'm going to sub in 1 for x. So I get 25,000 times 0.85 to the first power. Okay, so if I get my calculator out, 25,000 times 0.85 to the first power. And I get, so after 1 year, it is worth $21,250. Okay, that's after 1 year. Now if it asks 10, notice that the only difference is now I'm going to sub in 10 instead of 1. So everything else is exactly the same, except I raise it to the 10th power. So if I do 25,000 times 0.85 to the 10th, I got this to be $4,921.86. Okay, so those would be my two answers. As always, if none of this makes sense, make sure that you call me over so that I can explain it further to you. All right, let's do a different problem that you may not have seen before. In this case, we're going to be solving for the growth factor. So what we need to do is set up our equation. So it's still y equals a times b to the x. And a, well, Jose bought this car for $11,000, okay, and 6 years, and now the car's worth that. So if you remember, a is going to be what I started with, so 11,000 times, now we're actually solving for our growth factor here. So we're going to solve for b, so I'm just going to put in a b. 6 is the time, so that's going to be my exponent, and then the final amount is what they told us it's worth now. So that's $6,609.90. Okay, so we need a way to get b by itself. Okay, so in order to do that, the first thing we have to do is divide by 11,000. Divide by 11,000. Okay, so if I do that real quick in my calculator, 11,000, I get 0.606 equals b to the 6th power. Okay, so a little while ago, we talked about fractional exponents. So remember that in order to undo a 6th power, we need to do, okay, so if you have x to the 6th, the opposite of that is a 6th root, or in other words, that's raising it to the 1/6 power. Okay, so refer back to your notes on fractional exponents for this explanation. Okay, so I'm going to 6th root both sides. So in my calculator, it's going to look like this. 0.606 to the 1/6 power. Now, if you don't get what I get, make sure you call me over so I can show you how your calculator works, because sometimes some of them are a little funky, so make sure that we're doing it correctly. Okay, so I get B equals 0.92. Okay, so that would be my growth factor. Okay, and I can actually take it one step further. What percent depreciation is this? Okay, so if you think about, okay, well, if I'm multiplying by 0.92, how many percentages am I taking away? Well, that would be an 8% decrease. Okay, so that might be another thing that I ask you on a particular question like this. All right, so some of you may have noticed that there were half-life questions in your homework. Okay, and so some of you may have tried to figure them out, may have done them actually incorrectly, but that's okay. That I wanted that to happen. I wanted you to experiment with what would work and what would not work. So now, add this to your notes. This is the equation we will use for all half-life problems. Okay, so A is going to be the initial amount again. Okay, y of t is going to be the amount left, so that's kind of like our f of x. T is going to be the time, so however much time they tell us, and capital L is going to be the length of one half-life. All right, so here's the million-dollar question. What is a half-life? Like, what does that even mean? Now, this is, if any of you have been in chemistry, this is a chemistry concept. Okay, so essentially what a half-life is it's the amount of time it takes for something radioactive to decay by 1/2. So imagine if I started out with 100 grams of something, it's the amount of time it takes to decay to 50 grams. Okay, and then that same amount of time would take to get to 25, and then to 12.5, and so on. Okay, so this amount of time is what we consider one half-life. Okay, so they range from, hours to days to minutes, everything else in between. All right, but let's see how this is actually going to be applied in a real problem. So we have the metastable form of technetium-99. Okay, now you don't need to know what all this means. All you need to know is that it has a half-life of 6 hours. Okay, and you originally had 45 grams. Okay, write an equation that will give you the amount of technetium-99 after T hours and find how much is left after 31 hours. So let me just move this up real quick to give me some room. Okay, so again, what we're going to do is we have y of t equals a times 1/2 to the t over L. Okay, so A we know is how much we start with, so that's 45. Okay, so 45 goes in for A. Okay, we just copy down 1/2 because this is in fact half-lives. Okay, T is the amount of time that they're asking us for, so that means 31 hours. So we do 31 divided by, and then L is the length of the half-life. So they told us that the half-life is 6 hours long. So I'm going to divide by 6. Essentially what you're doing with this, let me undo that. Okay, essentially what you're doing with this by doing 31 divided by 6, we're figuring out how many half-lives have gone by. Okay, so if we type everything in, 45 times 1/2 to the, let me do this correctly. Again, if you're having trouble typing this into the calculator and getting what I get, just call me over and we'll figure it out. Okay, so after 31 hours, I get 1.25 grams. Okay, and one thing that I am going to emphasize on a lot of these word problems is the use of units. So I want you to make sure you understand what exactly is left over at the end. So in this case, 1.25 grams of technetium-99. All right, so I want you to try this one out on your own. Okay, so the metastable form of iodine-131, it has a half-life of 8 days. If there were originally 72 grams, write an equation of how much is left after 43 days. Okay, no, I'm like being serious. Like, stop this video and try it on your own before you go on. Okay, so I'm trusting that you stopped it and tried it on your own. Have an answer that you can check with mine. All right, so again, A times 1/2 T divided by L, and I'm just going to sub in all my information. So 72 goes in for A, 8 is going in for L, and 43 is going in for T. So I got 72 times 1/2 to the, let's see, what did I say? 43 over 8. Okay, so let's see what that is. 72 times 1/2 to the 43 divided by 8. And I got 1.735 grams. Now you could round this differently, obviously, but if you got something in that ballpark, then that is what you should get. All right, so I want to talk about a particular form of half-lives that occurs very, very often in the real world, and that's called carbon dating. Maybe you've heard of this before, but this is how they figure out how old fossils are. Okay, so they use carbon-14, and carbon-14 has a length of a half-life as 5,730 years. Okay, so this is in years right here. Okay, years. Okay, so it takes a really, really long time for it to decay, which is why it's so good at dating things that are really, really, really old. Okay, so same thing. T is time in years. A is the amount of carbon-14 originally found, and C of T is the amount of carbon left. Okay, so for an example, a fossil containing 20 milligrams of carbon originally had 45 milligrams of carbon. Determine the age of the fossil to the nearest year. So what you're going to do, okay, I'm going to do it up here in the top right. 20 is how much is left. So that's C of T equals how much I originally had times 1/2 to the T over 5,730, because ultimately we're trying to figure out how old this thing is. Okay, so what you got to do, you got to divide by 45 to get it to the other side. So real quick, 20 divided by 45 is 0.44 repeating. So I'm just going to do 0.44 to the 1/2 to the T over 5730. Now, right now, with the tools that we have, the only thing that you guys know how to do for this is to use guess and check, which is perfectly fine right now. Okay, so in the next coming videos, we'll actually learn a technique for how you solve these things. All right, so just test out some times that you think will work. So think about this. I need to raise 1/2 to a power to get 0.44. Okay, so like if I try this out, let's see, what's something that I would try? Let's do 0.5 to, I don't know, let's try like 25,000 maybe. Okay, and so what I got with that, if I did 25,000, so when I tried 25,000, I got 0.005. So that's way too big. So what I need to do is I need to go smaller. So let's let's see, 0.5 to the 10,000. All right, t equals 10,000 is also too big. Okay, I got 0.3. Okay, so still too big. So let's try something else. 0.5 to the, let's go 7,500. 5730. Oh, that one was close. That one was close. Okay, so when I tried 7,500, I got 0.403. Okay, so now I still need to go down, so let's go maybe 7,000. 0.5 to the 7,000 divided by 5730. And I got so t equals 7,000. Okay, 428. Okay, so I'm getting closer and closer, and obviously I can get it pretty close. But ultimately, it's going to be just under 7,000 years. So it's going to be 6,000 something. Okay, and so for right now, that's all I need you to do is just that guess and check and try to figure it out that way.